into this program, we are going to work on resumes of each and everyone in this session. So, because that is my assumption, everybody in this session is not a completely kind of a new person. So they know what they are looking for. So, and we would have everybody applying. So that whatever thing that is, so within this 1 month, my belief is that we are going to be able to acquire a lot that we can be able to get a job with that. So the work is going to be, in class like now and then out of class, which of all means it's not limited here. While we are away from here, we are going to have assignments, a lot of work to do. And also, yeah, I would always be there. Even when I'm busy, I can jump in. If somebody gets stuck, maybe 5 minutes, 3 minutes, I try to look at and see how I can resolve that. So you can get everybody going. So it's going to be very intense. So the expectations are very high, and I appreciate punctuality in class and also actively participating, in answering questions and all that. That actually helps me, because as an instructor, there are some days that I will go back home and will have chest pain. Especially in that session where you come and then, people are very sluggish. Nobody wants to answer a question, people hide behind the cameras and all that. But I don't think that's going to be the case here, because there's a few people. So it's very focused, and we are going to be very result oriented and all that. So that is that about little I have to say. So I'm going to share my screen and we are going to take a look, a little bit about the program, right? So, and from there also, base, we're going to measure the temperature of the class. And this is in terms of, how much comfortable people are feeling in particular aspect, right? So that we see where we need to focus our energy the most. We have to get the best out of everything, because we want to make it, as practical as possible. At the same time, very focused, a goal that at the end of this session, everybody here should, in fact, before we could even finish, some people should get jobs. That is the whole thing. And also, away from that, there's going to be an expectation at the level of applications. When we start application, it's going to be very hard, right? So people need to seriously apply. I mean, based on what I've experienced and also seen, the job market is actually opening up in a way that if you are positioning yourself well, you can easily pick your job. So it's going to be a great advantage if you could take that. So that is what I think. Now, let me share my screen, and we're going to move from there. And even before that, right? So if there is any question or something that I mean, you can ask, and we can able to go from there. Any questions and all that. So every class has been recorded, which recorded things are going to be provided accordingly. Actually, I used to have the recordings uploaded to the website so that people can have access to, but for now my storage is a little bit full. So, but I'm having a solution I'm going to put out in place maybe before Sunday, so that we can have everything. So it's not like, so it's going to just be a site. After the site, the videos are going to be uploaded, maybe additional notes, you can watch the videos, follow, and all that practice. So it's going to be easy. All right. So I don't know if you could see my screen.
Yep. And I also noticed that Moodle does not have voice, audio.
What?
Moodle does not have audio.
Oh, okay, yeah. So it's all right. Moodle is actually attending classes close to me. That's one of the reasons. So we are in the same location, right? So right now, that's why he's not having audio, but you can always unmute and then talk when necessary and all that, which is okay. So the first thing is looking at here, there is some rough curriculum for us. So in our first session, we're going to be looking at things, a general introduction. And this general introduction is going to touch, a lot of things, right? So in general introduction to DevOps, understanding the DevOps life cycle, assigning some of the main principles of DevOps, and then tools in DevOps, and all that, also skills that are required, right, to be able to become a DevOps engineer. So that's basically some of the things that we'll be discussing today, which I think is very important, right? So, I mean, it might not go the way that it is seen or you see here, it's here as it appears here. For instance, in module 2, we are talking about a general introduction or an introduction to cloud computing. So we might not necessarily in this module 2 go with introduction to cloud computing. Here you might see that we might go with Linux first, right? So before cloud computing, we might go with Linux first. And then after Linux, we are going to go with JIT, right? So we're going to learn, and we have days on JIT. So we have a lot to do with JIT, learning the JIT fundamentals and everything JIT related and all that. So everything that you need to know as far as JIT is concerned to work as the engineer, we're going to do that here, from learning the basic setting of your JIT and so on and so forth. And then we are going to, once done with JIT, we are going to move into Jenkins, right? We are going to move to Jenkins. And Jenkins here, basically is the center of CI/CD that we're going to look at. So Jenkins is used for CI/CD. That is CI/CD, continuous integration and continuous delivery or deployment. So we're going to look at that. What's Jenkins? We're going to learn Jenkins. We're going to learn how to use Jenkins to create pipelines from A to Z. We're going to learn how to build Jenkins, pipelines using scripted and declarative pipelines. So that's pipeline as code. I'm also going to learn advanced features in Jenkins like the master-slave architecture. In our distributed build, I always say when I'm talking about Jenkins and master-slave, one of the things I always say is that when you go to interview, please avoid using the word master-slave, because based on the historical, history, or based on the historical concept in which we are talking, sometimes the person that you are discussing don't know how he perceived those words. So you need to avoid them. How to avoid a situation that you might hurt somebody's feeling and all that, so politically and all that. So that is why they no more, in the current context, no more call it the master slave. They call it the distributed build in Jenkins. So it's no more master slave, but we call it Jenkins distributed build. Distributed build. So as it sounds, we're also going to learn a lot about what is distributed computing with the help of things like Kubernetes, most especially Docker. What distributed computing and so on and so forth, and containerization. We're going to learn that and all that. So I'm just saying, because I mentioned the word distributed, I miss a lot, especially in computing in the current context in which we are now. So distributed build, so no more master slave. Somehow along the way in class, I might use the word master slave, but be reminded, don't use the word master slave. Yes. So we're going to understand that. We're going to go into maybe further aspect of Jenkins, like shell libraries, and then security. That's Jenkins administration. How to configure, manage Jenkins administration, manage security, and any aspect of Jenkins to make sure that each individual can have only what they need. So we want to our pipelines and our access to Jenkins that to adhere to the principle of least privilege, and also utilize role-based access control to make sure that our resources and everything is secured. And then once we are done with Jenkins, what are we going to do? We are going to go into Docker. What is Docker? Docker is basically a tool for containerization, right? So we're going to treat everything Docker, ranging from Docker, basics, Docker Swarm, Docker Compose, and Docker Stack, which are going to be able to define exactly what are those concepts. What is Docker in the first place? Why do we need Docker? What problem, is Docker coming to solve? And equally, we are going to look at, like, the Docker native orchestration option that we have with Docker Swarm. And then we are going to go into, Docker Compose, and understand when to use Docker Compose, why Docker Compose, and we're going to go into Docker Stack. And then we got to understand how to use Docker Stack. What is Docker Stack and why do we need it, right? And all that. So then we are going to treat most of those aspects, ranging from networking, ranging from managing containers, storage, types of storage in Docker, and so on and so forth. And then, so once we are comfortable with Docker, we are going to go into Kubernetes, right? So Kubernetes is a Docker orchestration tool, just like Docker Swarm. So, but it has its own advantages and disadvantages. We're going to do a comparative study between Kubernetes and Docker Swarm and see why we might choose one over the other and why many goes with Kubernetes. In a normal circumstances, I could choose only Kubernetes over Docker Swarm, but for the sake of learning and for the sake of portfolio, we are going to do both. But we are going to lay more emphasis on Kubernetes because that is what actually is having the market out there, right? So meaning at the end of the day, you are going to learn and be very comfortable with Docker Swarm. You also see how you can migrate from Docker Swarm to Kubernetes and all that. So we're going to teach, learn the tips, tricks, and all that, how we can and go with it. And then we are going to further go into, after Kubernetes, we are going to go into, Ansible. What is Ansible? Ansible is a tool that is used, for configuration management, right? So if you, at the end of this program, it offers a lot of options and flexibility for you to work in many areas. So if you were to choose like, okay, I want to be more of a system engineer administrator, Ansible is one of the things that you are going to pay more attention to. Linux is one of the things that you are going to pay more attention to. And also with things like Kubernetes, because it falls under infrastructure and system administration and all that. So those are tools that actually push you, to go, but to go far and all that with your career. So it all depends. So there's going to be a lot of openings. So that means if you are comfortable, you could see a system administrator position, and you go ahead and you apply after this training. And like we're going to go into infrastructure as code with Terraform. So we're going to learn Terraform, right? So, and we are going to focus on AWS, Azure. We're going to set up infrastructure in AWS with Azure. We are going to focus, I think, more on AWS, setting up infrastructure with Terraform, and how to manage Terraform, different aspects of Terraform from the interview perspective and everything that we need, and all that, best practices. And then once we are there, here with the help of SonarQube, we have done Jenkins earlier. So you realize that even as we've talked about this, so before Jenkins does not work as standalone. You realize that from Jenkins, we will see how we start integrating these tools, seeing how to build them, work with them, because every tool that we are learning here is for a purpose. That's a purpose, a problem that it solves. But these tools sometimes they does not work as standalone. They work, together. How to build a complete solution. The aim here is not for you to just know how to do things in Jenkins, or do things in Kubernetes. No, the aim here is be able to learn and know how to connect the dots, across all those tools, how you can use them and what area you can use them. So that if you were to be hired today and you get into your company and they say, okay, this is what we have. Like, it's one of the projects I always give, a project that you are going to solve a solution. You are hired as a DevOps engineer, senior DevOps engineer, and this company is just a new company that needs, to adopt DevOps. They don't have a strategy, they don't know how to go about it. And you are a new person, and you need to, manage the effort to make sure you lead this project to success. Now, how can you be able to recommend tools? How can you be able to recommend solutions to the environment and all that? So all that we are going to learn in this process, so that at the end of the day, you should have a holistic, knowledge of everything, not partial and all that. So that's the game. You be able to build a solution, you'll be able to solve a problem, not having partial ideas left and right without actually connecting anything. So then we are going to use SonarQube, right? SonarQube, we'll see how to set up SonarQube and then integrate it with our pipelines, and then we are going to learn how to master to, analyze and so on and so forth with our pipelines using SonarQube. If possible, we can add additional tools as well that are not there for security. So SonarQube is basically a DevSecOps tool. So it falls under what we call, is it SaaS, static code analysis. So making sure that before we can actually deploy any code, the code is analyzed, check for vulnerabilities and any probable things that can cause problems to our environment. So we make sure it's properly scanned, analyzed, and then check for all that before we can actually go ahead and deploy it. So we're going to configure SonarQube, configure quality gate, and so on and so forth for our security, right? And then we are going to then learn Nexus. Nexus is used for storing artifacts. Now, when we talk about Nexus, there is Nexus. We have things like JFrog Artifactory and a lot of other artifacts that you have, even S3 bucket that can be used to store our artifact. And we talk about artifact in the DevOps context, right? I'm going to ask you guys this question, right? So, what do you guys understand by artifacts in the first place? Is it the first time you are hearing about artifacts, or have you heard about artifacts? And what is your understanding of what is an artifact? Anybody's open? No?
I always see artifact as like a backup history.
Okay.
Whatever we are doing in the pipeline. So like you download, keep what you were doing, keep track of what you were doing.
All right.
Yeah. That's simply how I look at the artifact.
All right, thanks.
Sometimes in the artifact, you can be updating and reminding you some of those things like that. Sometimes also have something similar like that with our phones.
All right. So, Madam Mary, you were about saying something.
I'm not sure, but
okay. Is it your first time coming across this word artifact, or have you come across it before?
I've come across artifacts before for DevOps and also for yes, for Agile, but I just don't know how to explain it. But I know that I don't know if there are files or there are folders that are stored or that are created throughout the software development lifecycle. Yes. So that's what I don't know.
All right, that's fine. So why I ask this is because artifact is something that is most valuable, as far as DevOps is concerned, right? So it's like the application, when the developers write the code, right? The code is just some code, right? So the code doesn't make sense to the end client, or in other words, the code doesn't make sense to an ordinary person out there, right? We ordinary people, let's say for instance, we are talking about WhatsApp, we are talking about maybe Facebook, YouTube, or all that. YouTube is a platform. Facebook is a platform, and it has an app and all that, right? So you and I using Facebook or WhatsApp, can we tell what code WhatsApp or Facebook is written with? Can you tell? No. So we cannot tell, right? So let's put it in this context. When we talk about artifact, first, you conceive an idea, a business idea, and you want to start a business, right? So you come up to me, maybe I'm a developer, I'm the technician. You say, hey, I have this business idea, I want to start a business. Well, I say, okay, great. And you need maybe the system, the app, or the website built. okay, I'm the system, I'm the guy here that knows the technical skills to do that. I sat down, or I sit down with you and I ask question, important question. What is this business all about? Right? So you give me explanation. Maybe is this business going to be a gas station? Is it going to be a school? Is it going to be a bank and all that? So as you are talking to me as a technician, I'm taking down your requirements. I'm understanding your business. I'm taking down, right? After taking down that requirement, I'm going to make analysis. My financial analysis. Now, let's say in a banking system, maybe in the bank it has departments, or it's maybe let's see what. So it could be anything. So you're gonna look at what departments are involved and all these things. You're going to do your information gathering. You're going to put all these things together, and then you're going to come out with what I call a business requirement document. We are going to discuss with the application owner, and then once we are comfortable that you've understood the concept and he himself is satisfied with everything you have presented in the business requirement document, you are going to go to work. And when you go to work, what are you doing? You are going to get a developer in your team to start working in developing this application. Now you are the end client or the business owner. I am the technician, the developer. I am the one writing the code. Now, your interest as a business owner, the end client, is not my code. Your interest is the application. Now, why is this important? It is important because after writing the code, I need to convert that code into something. That something is what basically we call an artifact. And this artifact, if you have downloaded, for instance, WhatsApp and install on your computer, you download something on the internet and install on your computer. Let's say, Word or any application, Adobe and so on. That particular thing that you downloaded is a piece of code. That is what is called an artifact. It is that code that is converted into that particular executable file that you have downloaded and you can be able to do click, and then install, right? So an artifact is basically when you convert that code into something that the end client, the user, or the end users can be able to have it, the application installed on the system. That thing that they are installing is what we call the artifact. The artifact is basically the end goal of the application. So further explanations might come in as we move, right? So it's good to understand what is an artifact, because you're going to see this artifact in DevOps. Even at work, they're going to talk about artifact and all that. So the build artifact is basically once the artifact, or when we talk about the build, right? Those are things that I'm going to come into. So now, basically, what am I talking about here? We've talked about Terraform, okay? We've talked about SolarQube. We've talked about Nexus as an artifact, manager. So Nexus is a repository that you can store the artifact. Why is this important? I have taken a long time trying to explain what is an artifact. It is the application itself, because if you lose the artifact, it means you have lost the application. So the artifact is the application, and that's why you need to protect the artifact. Whenever they build the artifact, they convert the code to an artifact, right? They don't just allow it, right? They don't just deploy and then let it go. No. When you convert the code into an artifact, you need to preserve the artifact. You need to back up the artifact. And that is where things like artifact managers come to play. I have talked about Nexus is one. We have JFrog at factory. We could also upload our artifact to things like S3 bucket or blob storage in Azure, right? So companies can back it up in whatever way possible. There are a lot of where they could back up, but you must back up the artifact, right? It's just like a good example is Android. We always have for instance, a notification whenever a new version of Android is released. Why is that important? It is important because, right, they keep updating. When they make change, whether they have patched an application, because of security vulnerability, or they have added some enhancement and all that, they upgrade, right? And then that's why it is being pushed out. That process of pushing out actually is something we're going to understand in the process of a DevOps life cycle. And you receive that new version. So you will see version 100, 1, 2, 3, 4, 5, 6, whatever we are now, right? Those are different versions of the same application. Those are basically artifacts. If you go back to the company that owns Android, they can go back to the first version, right? So the artifact manager versions the artifact, so it keeps the artifact history, the versions. So the artifact could be an executable file, could be just a file, as you guys have talked about and all that. But all underlying idea is that what it is the underlying application. So if you mess up with the artifact, you have messed up with the application because it holds everything that is needed for the application to function. So the artifact manager, it keeps version just like JIT, version control, and all that. So that is what Nexus is all about, what you're going to see. And then we are going to go into AWS services. We're going to treat a lot of AWS services here, right? So we are going to treat, we may not treat all, we may treat all, it all depends on time, but we are going to treat the most that you will need to be comfortable as a DevOps engineer. And then we are going to also touch Helm. You're going to learn, going to teach the tips and tricks of using Helm and Kubernetes. Helm is a Kubernetes manager, right? So how to use it and all that. And at that point, I don't know if I'm omitting anything here. We are going to go into, resume. However, we are not going to end the last. You have to go into the resume building. So once we are into this for 3 to 4 weeks, we would work on getting those resumes ready, and we will, get into the job market and all that. And that is a quick overview of how a program is going to look like, right? So I don't know if I've omitted anything to talk about in this overview. So with this overview, right, I want to hear from you. How do you feel? Does it meet your expectation? Is it too much of work? How do you feel about it? Madam Mary, what do you think?
No, I think the program is good. I just want to know that how many days a week are we going to be having class, and how many hours a day?
Very good. So that is very important, right?
Mhm.
So I am trying to do my best to make it, I think, 2. Or because I don't think I can, 2. I think we are going to have maybe, depending on how it's going, and also, how you all are doing, it might motivate. And if I can say how to twist time again, add another day for us to do more. But when I see people with, need more, I always give more. That's why even the Bible says, he that has more was also added, So if we could show that we are improving and show passion in this thing, trust me, I can do more. But for now, we're going to go with Saturday. Fridays and Sundays. I believe Sundays in the afternoons works well, right? I know we talked about this for sure.
For me?
Yes. Sunday afternoon. How does that, is that, one thing, I'm not going to come back. I know that 2 people are supposed to be here. They haven't shown up. And let me check if they have left a message or not. Yeah, no show, nothing. So that's fine. I'm going to leave them behind. There's no time. So what do you think? What do you?
No, I'm okay. My Monday, Saturday, Sunday. What time?
I believe maybe 1 p.m. How does that sound? 1 p.m. Because I know people go to church in the morning and all that. Is that too much?
No, I don't want to drag everybody behind, but for me, Sunday is 3 p.m. I don't know if Mr. Mu is okay with 1 p.m. Then I can walk around it
3 p.m.
on Sunday. Yeah,
Okay.
I'm always available.
All right.
it's an availability zone.
Yes.
I'm always available.
Okay,
All right.
thank you.
Okay. So I think 3 p.m. is not a big deal for me. I can go at 3 p.m.
Okay, so Friday 8 p.m., Sunday 3 p.m.
Yes. Why is this? Is because I already have some lot of activities going on, and also I want to get some little time for myself. You know, in as much as the energy is released, we need to also nourish and have some rest as well. So that's the whole thing. So that's the rundown of the program. And if there's no further question regarding the program, I am going to go into now to actual, introduction to DevOps, right? And maybe we can talk about.
If everybody was here, we could take Saturdays to discuss and see how we arrange even 2 hours of Saturdays, just like good work among us.
Anyway, yeah, you can have revisions and work, which I will highly encourage. But I cannot make it on Saturday as a person. Yeah.
No,
so
it is not concerning
yeah.
the teacher.
All right. Yep. No, I'm okay.
That's why I was saying that if everybody was here,
yeah,
let's actually know whether Saturday is free or.
Yeah.
But will they join the class eventually?
Sorry.
Will the other people join the class?
I mean, they were supposed to be here. There's some. I mean, a lady in Oklahoma and then Ohio, so they are not here. If they are not here, I don't know why they are not here. But trust me, I mean, I have been into this thing for some time. People need to have that self-drive.
Yeah.
If they don't have it, you cannot force in this thing. I've seen people that came here that they knew nothing. And I put in a lot of energy. And by the time that I start seeing them, coming up strong, they just get up like this and just make an excuse. And I felt so, disappointed with a lot of, because I mean, I like to see people succeed. I put in energy, but you cannot force this success on people. They just get up, you look for just one flimsy excuse, and that is it. So the more that you are trying to pull somebody, right, and the person doesn't have the willpower, somehow along the way they will go. So I don't hold nobody. I will teach one person that is ready and I'll be satisfied. And the policy is that if it's only one person, the class will be like they were 100. That's the policy. I don't have to be, because you have that, everybody have what they are after. So I mean, that's the whole thing. No, nothing. So we all do our best sometimes to follow up, but we cannot, force it on people. So they got to make that decision, and we are here to help. So I'm very excited and happy. It's and that's all. So things there is is there anything that maybe you'd have loved to see on the program that you haven't seen? Anything? Anything? I know I've mentioned that we're going to touch. I mean, the smaller the better, because it will give us a lot more flexibility, to be able to do more and all that, which is good. So that is what yeah, Azure is not there actually, because Azure DevOps normally is supposed to be a program on its own. But sometimes for the benefit of the people, I sometimes would want to give them some fundamentals on Azure DevOps, because Azure DevOps is also hot cake out there, right? Like, you can get trained in other aspects, but you realize you end up getting yourself working on Azure DevOps. So which is good to at least have some ideas and do some basics before. So that's something that I dedicate. It's my extra effort to give more, so that they can, have that. So, and things we can add on the way, I believe. Now, so I'm going to open up whiteboard, and we are going to start seeing some of the things talking about DevOps. We are going to start even asking our question ourselves, what is DevOps and why DevOps in the first place? Which are important, very important questions to answer. Right? I mean, the questions of whys are always very important because they drive us towards purpose. Get to understand, and also we need to also understand some little backgrounds which are going to a little bit run through some ideas. Like for instance, I always sometimes dedicate time to talk about the background before DevOps, which is some of the things that are important. All right. So I am opening up this whiteboard. Let's see. All right. Guys, I'm not very good in this whiteboard thing, so but just permit me. All right, so I can write. Yeah, so my whiteboard is right. Let me see, erase again. Where is my erase? Where's my eraser?
Come to the left side, let's see. More tools at the bottom.
Yeah.
Not there.
All right, so now we're talking about DevOps. The first question that we are going to ask ourselves is, what is DevOps? All right. What is DevOps in the first place? That's the first question we are going to ask ourselves. What is DevOps? That's the first question. All right. So we've talked about DevOps. I've heard it in small letters and all that. However, let me put it the way it's supposed. So it's DevOps, and the O is also P, which is important, right? So what is DevOps? I don't really think that this whiteboard, it's the best for me. I don't really know how to use it very well. So, what is DevOps? That was the first question that we got to ask, right? And asking the question of DevOps is very important. So, Mr. Mu, Madam Mary, what is DevOps? What do you understand by DevOps in the first place? You understand by DevOps?
Okay, I can try.
All right.
So DevOps is I'll say a framework that was born after that was born to supplement the agile framework of building software.
Okay.
So it is a situation where our development and operation teams will no longer work in silos, but they'll work together to bridge the gap and ease the friction that existed in the past between the development team and the operations team, wherein the operations team is expected to maintain the production environment of the code that built out of the code that the development team had already built. And so without having to talk with the developers beforehand, so they did not know what was going on. And if they had questions, there was nobody for them to answer. And so the DevOps framework was born to bridge this gap between these two teams, wherein they could work together, build software, deploy the software to production, maintain, how do I say maintain? Like watch, and then keep getting feedback from the operations team is deploying that code, watching the environment for bugs and vulnerabilities, giving feedback to the development team, build future code and just like that. That's what I know.
Thank you so much. That was very good. Now, as always, in an interview, whenever you mention something, it is always calling up. In the course of your explanation of DevOps, you mention something agile. If I'm an interviewer, I'll be very curious. I want to know what is agile. And that's why you see me again. I put another question, what is agile? Which is very important.
Okay. So agile is typically an incremental incremental structure of building software wherein we build in small batches or small increments. We deploy to our customers, we get feedback, and based on their feedback, we continue working on the product or we make adjustments as needed, which was born to take care of the shortcomings of the waterfall system that existed before, wherein we only had customer feedback at the end of development.
In fact, thank you so much for that definition. In fact, you have given us everything about agile. That's amazing. Continuous feedback. Those are some of the points that I tried to take. So anyway, yeah, very important. Very important. You have touched, and again, I could start going to waterfall. Those are key points you have touched, which is very important. So I like the fact that you are defining this thing and you are giving all these things. Very important. And I like the fact that you are talking about it with so much confidence. You are very knowledgeable about the whole thing. That is very amazing. Why is this important? And why am I pointing out also? You know, in an interview, sometimes this is just how an interview can look like. In an interview, they are going to basically like, okay, hey, thank you, right, for accepting an invitation to interview with us. We are going to first of all tell you a little about this company, this project, and all that. And once they are done telling you about themselves, the company, and all that, introducing themselves, the next thing they're going to say, okay, you know what? Hey, sis, can you tell us about yourself? And now you start talking, mentioning all these technical terms and all sorts of things. As you are talking, the person at the other end, sometimes they might be jotting down those things they're taking. And that is how some interviews are going to end up. They're not going to come with any pre-prepared mind, but they are going to come open to learn. They will say, you know, tell us. And just by telling them about yourself, you would talk about this thing. You've mentioned agile, you've mentioned waterfall methodology and all that. It, you know, still curiosity, and they want to know more. And they'll start asking you questions. So you can end up, that's how an interview sometimes might be. Some would come with pre-prepared questions. Some would come with a very open mind, ready to discuss your background, ready to flow with you. And so you have control over it. And that's why when you're in an interview, you need to be very mindful. Anything I mentioned, you should be ready that if they were to ask a question, especially key things, that's why you have the power to control your interview, to go in your own direction when you understand the psychology of everything. You'll be able to, you know, throw all these things around. When you throw all these things around, it's going to pique their curiosity and you want to know more, especially in the areas that you know that you're comfortable, and that is how you start flowing, you know, and that is how at the end of the day, you're going to win the points to be able to get that job. That is very important. It is a game, and all we need is to understand that. So that is very important. So we've talked about waterfall methodology. Let's start from there. Before Agile, we have had waterfall methodology, which is very important. And I'm not going to go more depth into what is waterfall methodology. However, what we need to know about waterfall methodology is basically is a software development strategy or methodology. And one of the key things is that it follows a linear approach. When we talk about linear, we mean step by step. It starts from, you know, information gathering, research, you know, planning, and so on and so forth. Software development have about 7 stages. You know, we have planning. I mean, we have research, information gathering, research, planning, you know, coding, development, and so on and so forth, maintenance. So it's, I mean, there are about 7 stages of software development. So one of the key things to Agile is that it follows a linear approach, step by step. And this could be good and it could be bad. So it has advantages and disadvantages. What is the disadvantage of waterfall methodology? First, in waterfall methodology, you must finish one section before you move to the next. It is a step-by-step approach. That means you must finish step 1 before you go to the next step, before you go to the next step, and so on. And because of that, sometimes it slows down the process of production, right? It slows down the process of production. So the waterfall approach also is very ineffective when it has to do with big teams, large companies developing an application that is going to, for millions of users. Waterfall methodology can work in a context where maybe it's a small company dealing with fewer customers and all that, right? And it's easy to manage. That's one of the advantages. It is easy to manage because what? You already, at the onset, you know what are the steps that are going to be taken. Right? So you know that I'm going to live from this information, gathering information, researching, analyzing, planning, coding, and so on. No, it's a step-by-step that is already there. Now, which is a good thing, right? Setting a goal, knowing what to face is always good. But things change, right? We live in a fast-paced world. Things might change at every given time, right? So with this approach, it is not flexible, right? It is not flexible. And that brings a problem because things might change. Not only can things change, you might plan from gathering information, planning, analyzing, coding, and just to reach a level of delivery and get to realize that all the time that you have wasted trying to put those things together, they basically did not even align with what the end client was looking for. And that becomes a problem. Why is that? Because there is lack of continuous feedback in that process. The end user is just there, or end client is just there, not knowing what is actually happening at the back end. There is not fully participatory in the process. So there is that communication is not actually flowing as is the case with Agile. And all the stakeholders are not involved in the process. And that it becomes difficult, right? And second, the fact that it takes time, step-by-step approach, it does not give anything to the end users to be able to depend on. So if we have to take 1 year to develop this application, that means they have to take 1 year waiting because we have to complete every step until everything is done, and then we have to develop the application in full. Now, not knowing whether it's going to be rejected or not. I once had a situation with one company where they actually was trying to get me to work on a project. That project was being worked on by another company, but they did not deliver, and they had to take away the contract from them and then give it to another company. After spending maybe 2 years and all that, that is a time that nobody wants to waste in the business world. So what is the challenge with waterfall methodology? Waterfall methodology does not have all the stakeholders are not fully involved in the process, right? There's no, continuous flow of communication, right? It is slow. It takes a step-by-step approach, right? And then at the end of the day, it might not give what it wants. And second, it is not flexible to adapt to changes. And that becomes a problem. There is a lot that we can say about the form methodology and all that. There's just a lot of things, but I'm trying to say it in my own words in the simplest term that we can be able to understand. Because of this, right, the problem now, we keep improving, right? So they start looking at what can we work out with the problem first with waterfall methodology. And that's where Agile comes to play. Agile comes to play to solve some of those problems. And one of the key things about Agile is that we say something that Agile is a just-in-time solution. How will I put it again?
Framework.
It follows a just-in-time framework or approach. Now, contrary or in contrast to waterfall methodology, what Agile does is that what Agile breaks down the work into smaller bits. That is the first thing about Agile. Instead of having to, because everything in waterfall is bulk, right? Work in bulk, step by step. There is no flexibility, and it becomes difficult because one of the key challenges is that if something breaks, you don't know where to start fixing it. That's one of the problems with waterfall methodology has a lot of things because it's in bulk, not flexible. If something breaks, it will be difficult for you to fix. How is this possible? Look at you plan. You have gathered information, you have analyzed, you have planned, you have developed, you have tested, and now you have reached a last level and something is failing. It's difficult. You will not even know where did I make the mistake. Maybe at the test level, things are failing. It's not meeting up what you're looking at. Where are you going to? Did it start from maybe the information gathering? Is it that we did not get things right? Or was it at the level of analyzing or at the level of coding? It becomes confused. But if at any point, like you mentioned earlier, if we had break down this right into smaller bits and make sure that every change that we made, we integrate with tests. Any change that is made, we make sure that we analyze it, right? And then we would be able to know that, okay, if something fell at this level, we can be able to know, okay, the previous level was successful, this one was successful, and so on. We don't have to wait to the last minute. That is a problem. Security-wise, it is not good because in security, they will talk about love shifting approach. And love shifting approach in what means you have to start your application development from inception with security in mind, all these aspects, asking the question of what possibly can go wrong and start putting in place, possible solutions. So that's why I would say, whenever you plan for the best, always ask yourself, what if the worst happens? It is not for you to be scared, but it's for you to have a ready mindset to face those challenges and think of possibilities of how, if the worst happens, how can you be able to go about to resolve that, rather than for you to be hit, unexpected. So a just-in-time approach in Agile. First, we talk about it breaks down everything into iterations, sprints. We talk about iteration, we talk about sprints. Now, what are iterations? What are sprints? Iterations or sprints, basically, in most environments that they use Agile, basically, they have, at the beginning of the year, they have a period, like they have quarterly, and all that. They have a task, they have projects, right? They have a plan of how to deliver those projects. Now, they take the project, the breakdown. This is in the first half, this is what we are going to achieve. In the second half, this is what we are going to achieve and all that. And within even those first half, right, they break it down into months, monthly. For instance, an illustration could range from anything 2 to 4 weeks at most, in most cases, in most environments. And within those 2 to 4 weeks, they have what they need to deliver, and they have criteria that they have established. What criteria are we going to measure success within this period? Right? So those criteria need to be defined. And secondly, they need to, have a user story. And when we talk about user stories, which is key things, which, somebody could ask in an interview, what's user story? User story basically have criteria. First, the criteria is that one must have a value added something. Now, when you are writing a user story, let's give an example of, I want to build a car. Now, we can have a user story. Let's say, okay, in this illustration, what is our user story? We can have a user story and we say, okay, we want to build a car. And this car is going to take us 2 years or 3 years to build this car. Where are we going to start? That is the question. How are we going to establish a user story in this scenario that's going to add value to the customer? Because everything that you do, you must do with the customer in mind. So Agile, right? Make sure it simplifies this process and makes it easy, breaking it down into iterations as compared to waterfall. And then second, it makes sure it's a just-in-time approach. What about just-in-time? It means that it must have a direct impact right now on the customer. It should not keep the customer waiting for 3 years. No, think about a way to add value to the customer right now, just in time. So now, a good user story, building a car. How are we going to start? Are we going to start with tires, the body, the engine, what are we going to start with? Now, if we start with tire, okay, it is considered something good, right? So we are going to put a tire, we could say within illustration 1, we are going to develop, to deliver this tire, which is a good thing because part of the process. But now the question is, what value is that tire going to add to the customer?
Nothing.
You see that?
Nothing for now.
He's not going to add nothing, to the customer. Therefore, that user story in itself is not valid because it does not add a value. And second, how are you going to define, success within that process? So those are things that needs to be answered. Now, in a good user story, following a just-in-time approach, you say, okay, you know what? Instead of starting with the tire, we can start with the bicycle. Do you see that? Now, this is what is going to trigger that continuous. What did I write here? I wrote something, right? That continuous feedback. Yes. Why? Because you are going to develop a bicycle. The bicycle is not the end goal, but I think it's going to give something to the end user to have to depend on. He's going to be seeing, to be involved because he's going to be experimenting, his invention. And by so doing, he could say, okay, driving the bicycle, he knows that he's expecting a car at the end of the day, but that car is not forthcoming. But with that bicycle can be able to take him from one position to another. And by so doing, it's going to keep the customer engaged. He will drive the bicycle and he will give feedback. He says, oh yeah, I love this bicycle, but I think this improvement, that can be made. And then you, the technician, the developer, the contractor, they are going to now go back to work and say, okay, based on this feedback, this is how we are going to, and so on. So from illustration 1, the end user serving is directly involved. All the stakeholders know what is happening. They're able to make some inputs into the process instead of having to wait for 3 years just for them to end up with a disappointment because what was delivered did not meet expectations and could not fulfill its purpose. So you realize that in the agile approach, like you've rightly defined, I'm not an agile guy and all that. I'm not an expert in agile. I should have rightly defined, right? Incorporate all these things, continuous feedbacks, breaking down the work into smaller bits, and distribute it across, right? And making sure that it's delivered in the sprints. And by so doing, we can be able to easily identify faults along the way. And also we can be able to know that we are meeting the needs of our customer because we are getting feedback from them continuously, making sure that every change that is made, that change is integrated into the process. When the end user or when the customer comes and says that, oh, the bicycle is good, but I think it could be done, this could be done, and so on and so forth. What do? We take that feedback and then we work on that feedback, we make an improvement, and we integrate the improvement into the process, and we give back something in the next session. Instead of just giving maybe an ordinary bicycle, we can give bicycle with 2 tires. That brings in more stability in the process, and so on. So is that by the time that these 2 years goes down, we are sure that whatever thing we are doing, the customer was involved. And second, it's difficult for the customer to come and say that, they did not deliver what he has, requested or he has asked for and all that, right? So there is just a lot we could say about agile, right? But at a basic level, we say that agile is a just-in-time approach. Agile basically does what breaks down the work into smaller bits, what we call illustrations. You have user stories, you have things they call epics and so on and so forth. There's a lot of technical terminology that is involved in that process. But I'm not an agile guy. But my goal is at least understand what is agile. How does agile work? Understand what is waterfall methodology and how it works. And now the question is, now what does this got to do with DevOps? What does this got to do with DevOps? That's where we are going into. Right? Are we together?
Yes, Prof, I'm here.
All right. So there is this diagram that I always like when I'm talking about DevOps. I don't know how to draw. There is this diagram. I wish I know how to draw. I could have used my screen, but I did not set up my whiteboard. So you were actually right, Andy. So here we have DevOps. So I'm not going, and then here, yeah, let me say DevOps. If it's not done. And then here we have development. Oh. Development. And then I could abbreviate it as just dev. I'll get a pen. I didn't set up this thing. I'm not very good in writing. When I draw a thing, it's not going, I don't like the way it looks. It looks funny. Okay, I will just represent it in the form of letters so that we should know. I will put dev and then let me try drawing it again. I could look at it. And then here we have ops. We have ops here. Ops. We have devs. Dev is abbreviated. And then we have DevOps here. Yeah, DevOps. Anyway, so, however, I just understand, even if it's not clear. So before DevOps came into being, we have talked about Agile. However, despite the coming of Agile, there was still a problem. Because even with Agile, there still was that gap between the development team and the operation teams. A development team develops application. It sends the application to the operation team. And the operation teams start asking, are you sure this application is not going to break down something in our system? How sure are we that this application is safe? You know, there is a conflict between the operation team because the operation team does not understand how the development teams function, and the development team does not understand how the DevOps, the operation teams function. They work in silos, right? They work as separate entities, right? So that anytime when there is something to be developed, there's always confusion, conflict, and so on and so forth. And with that, that is where DevOps comes into play. A DevOps engineer is not a developer. He is not, you know, the operation team or the ops or the system administrator, because the ops here has a lot to do with, you know, administering, system administration, and so on, and all those things, engineering, and so on. So a DevOps engineer is basically an intermediary, you know, between the development team and the operation team. And he understood, or he understands how the development team works, and he understands how the operation team works. So it comes into play to synthesize or synchronize these two teams together. joining them together to make sure that these two teams no more work as in silos or work as individual teams, but they work together as one. Right? And this is possible thanks to the fact that a DevOps engineer is he that has, masters some skills and tools that he can be able to use, right? Without having to have the DevOps team send the code now to the operation teams, and the operation team get confusing again and questioning. Rather, right, he set up a system that can be able to basically automate this whole process without having to get this conflict anymore. Now, this is only possible with tools that are placed at the disposal of the DevOps engineer, right? So the development team knows how to write the code, but the development team doesn't know how to get that code, to the end user. It does not know how to make that code a complete functional application, right? So that can be used by the end user. So he writes the code, he has to send it to the operation teams. Now the operation teams, is not sure and doubt everything. A DevOps now comes to play and say, okay, now let us do it this way. Instead of writing this code and sending it to the operation teams, we are going to basically put a system in place, right? And integrate the tools that are needed by the operation teams and the development teams, and make sure we make a seamless process. A seamless process that can be able to facilitate, the flow of software development lifecycle without all these, roadblockers anymore. Now, what is the first goal? Just like Agile, one of the key things about DevOps use Agile methodology, Agile approach in its process, but DevOps is not Agile, right? So DevOps has methodology, use Agile approach, but DevOps is not Agile, right? One of the key things in common is that what? It is to shorten time to market, right? It wants to remove all these delays that has been caused by this confusion so that this application can reach the end users in real time. So we don't have to develop application and it take months. We want to make sure that in a day, we can even in a single day release multiple versions of the same application as the changes, improvements are made. So those changes and those improvements are made readily available to the end users through the DevOps flow. That's the first thing. So the number one reason of DevOps was to shorten time to market, remove complexity, enhance, deliverability, and keep it simple, right? So short time to market, simplicity, enhancement, and so on and so forth. Those are different aspects of DevOps that are very important. Now, let's look at it now here. So DevOps use, for instance, first, JIT, version control systems. So when the code is written, the code is not supposed to be sent. Before now, in most cases, they used to write the code and they have to maybe send the code to somebody in the company, the operation team, or the testing team, and so on. They have to test and a lot of process. But now, first, in the DevOps approach, everything is simplified. They have a centralized location where that acts as a repository, right? A repository is basically a storehouse or a storage, in other words, that you could store things. A warehouse, you could call it a warehouse, but this warehouse is a code warehouse. What happens? You store everything. When the developers write the code, they deposit that code into a repository, right? There are different types of repository you could use. For instance, in Azure has what they call Azure repos. right? It's used JIT, it's JIT, but it's integrated in Azure. AWS has code commit, right? And then you have GitLab, you have GitHub, and then some people use things like, you know, you have what they call a Subversion, you know, Bytebucket. Those are different version controls. But one of the most used is what JIT. And why we're going to get into that when we get to JIT. So once the code is stored in this location, first, what do we say? The DevOps engineer is not a developer. The developer is the one that writes the code. When they write this code, they store the code into something called JIT, right, in the JIT repository. And it is in this JIT repository that the developer, the DevOps engineer comes to play. So the developer now comes to play and then say, okay, as a DevOps engineer, this code is ready. He's going to pick the code there, integrate the code with different tools. For instance, Jenkins, for instance, Marvin, Gradle, and all that. So first, it is going to check out the code. In other words, download the code from that repository that has been deposited by the developer. Once it downloads the code, it is going to build the code. So by building the code, in other words, it is going to convert a code into a usable artifact, into a usable application, in other words. So whenever you hear about build in DevOps engineer, in other words, it simply means converting the code into something that we can use. Converting the code into an artifact. The code is the raw material, but we need to convert the code into an end. How do I call it? Into an end result, right? To a finished good that can be utilized. So in that process of converting that code into an artifact, because the end user does not know how the code looks like. He does not care to know how the code looks like. All he cares about is the application. As a consumer, you know, of maybe motor vehicles, I don't know how they come about with the engine. I don't know how they come about with the tires. You know, I don't care about the process. You know what I care about? I care about the end goal. And what is the end goal? It's the vehicle that I can be able to enter and you can take me from one location to another. That's what I care about. That is the same concept here with, you know, in this process. The end user does not care what the code looks like. All he cares about is the end goal. If it is WhatsApp, he should be able to have WhatsApp, he can download, install on his phone, log in, and then do business and communicate with his family and friends. That is the goal. He does not care whether I use Python, use Java. In fact, nobody that uses all those platforms even knows what they have been built with. We care about the end goal. So therefore, they need to devise a means to bring this result to us, which is in the form of what? The finished good. So the work of the developer ends at the developing, writing the code. Once he has written the code, the developer engineer comes into play. What he does is that what? He integrates this code, he builds the code. And in this process of build, there are tools that we are going to use. First, the code is deposited into JIT repository. So therefore, as the developer engineer is somewhere that has mastered JIT, he knows how to work with JIT. He can do JIT pull, JIT push, you know, JIT merge, and then resolve conflicts within the repository of JIT. Right? So he's going to check out the code. You know, I will download the code from that repository and he's going to convert the code. And in the process of converting the code, there are tools. Right? For instance, Marvin is one of the tools. For instance, this is a Java-based application. There's a code base called Marvin. We are going to use Marvin in our process. Right? So Marvin or Gradle, it could be whatever build tool out there, depending on the type of application. We are going to use Marvin because we are going to build Java-based applications and all that, right? So once it converts the code into an artifact, it is going to test the code to make sure the code works. And so in that scenario, it's going to upload that artifact or upload the code into the test environment. So in real world, there are always multiple environments. The development environment would use the development environment, the dev environment, to play around, test their code, to make sure everyone develop their code. While develop, the development engineer is going to build the code. Once they build the code, it's going to automatically deliver the code into a UAT environment. Into a UAT environment. UAT. I should better be going with the right thing. It's going to put the code UAT environment. So we have three environments. We have dev, we have UAT, which sometimes also QA environment, right? And then we have, or what is the other environment? So we have QA, dev, UAT, and then we have prod. I am missing one. Which one am I missing?
Stage.
Staging.
Yeah.
Yeah, or staging. Yeah, staging sometimes might also be called this. Let me just put staging. Sometimes it's also called UAT or all that. So it's all right.
Then you're missing the local environment that we'll be working on.
So let's say staging. Yeah, so local. Yeah, let's take locals here. For instance, local could just be a local computer. Let's say local environment. So the developer is writing the code in their own environment. So let me just maximize a little. So now the whole of this process is automated. What does that mean? When he builds the code, when he developed the code, it is deposited in the repository, in a GitHub repository. So from the GitHub repository, what do? We are going to download the code there. Not about download or checking out the code. We download it to the system in which we have to build, because in order to build the code, we need some particular tools, and those tools, are configured within a particular system that meet those requirements. And which we are going to see, like for instance, agents. We are going to understand what are agents, because that need some compute power and need some compute environment from particular, environment is configured with certain tools to be able to perform this task. That's why we have to download it from the repository to those environments. We are not manually downloading it, we are automating this process. So we're going to download it either if we're using Jenkins or we're using Azure pipelines or Azure DevOps. The process is going to be automated, right? So once you download, the next thing is that it's going to build the code, test the code, and then deploy the code. At the first level of deployment, it's going to deploy it to the staging environment, right? From the staging environment, yeah, good. So this let's say test. Yeah, I was missing test, which is also test. Yeah, I could also call it staging, like you rightly said. Yeah, so test and then UAT. So it's going to be maybe, deploy here for additional testing, because there are so many types of testing. It could be user assurance testing, it could be functional testing. There are so many types of testing, and that's why there are other guys, developers that are specialized in just writing these test units, right? Either with Selenium, JUnit, or whatever framework they are using for this testing, depending on the type of application, right? It could be Selenium, it could be JUnit, it could be whatever frameworks that are using, right? So now they are going to have another repository that have the test code deposited into it. And they're going to tell you, hey, Madam Mary, hey, Mr. Mu, this is the repository in which we have deposited the code. You don't know how to write the code. You don't know how to write a test unit. If you know it, that's fine. But you know how to integrate that test unit to make sure that perform a task. So you are going to pick that and then integrate that and make sure that test unit is automated. It is executed automatically, right? When it tests, them are conditions that are going to be defined. What should happen if it fails? Should it continue or should it abort? Right? So those are logics that are going to define your pipelines, which are going to see all those things. And if it fails, should it just stay or and all that? Right? There must be something. And that is feedback. You need to send feedback to the stakeholders, especially who is in charge. It is never a good practice anyway to just send random emails to everybody when something fails. No, there must be specific people that are in charge, that they know they're also, they must be notified when something fails. Like test, if fail with testing, there are two questions. Is it problem coming from the developers and lower the code, or is it problem from the pipeline? If it is problem from the pipeline, it is your responsibility to resolve that and have it running. If the problem from the testers, they miss something in their code, what do? You have to revert back to them. Once you revert back to them, they are going to do to rewrite and fix the issue, the bug, and then re-upload the code to the repository, and it's going to start back from scratch. It's going to download, it's going to build. It's going to download, integrate, build, right? Test. And if part of the test is going to go to the next stage, it's going to deploy now to the UAT environment. And from the UAT environment, if everything is working good, they are going to further observe it. In most companies, like big companies like Google, Facebook, sometimes if it's a new application that they're releasing, they are going to grant access to internal users. They are going to experiment. They are going to get feedback, right? And if they get feedback, right, because this is the whole thing. It is not just about the code. The code might be functional, good and everything. Good, but the functionality of the application, the experience of the application from the end user is not the best, right? So that all those feedbacks, comes in now. They're going to now, okay, look at, say, this is what we're going to do. We're going to improve in this area. We are going to improve in that area, and so on. So they're going to integrate all that and then improve. And then from there, once everything is ready, they are going to move now to production, which is the final environment where it is made available for end users. Just like whether it's ChatGPT that we have today, whether it's Facebook we have today, whether it's whatever thing, it goes through this process. Now, I'm just giving you some rough kind of explanation, right? So I've explained all this to you without, mentioning. What is all this that we are explaining? All this is what we call the CI/CD, continuous integration and continuous delivery or deployment, depending on what concept we are talking about. CI/CD. CI/CD. So this process is basically, now, the first process is what? Continuous integration. So continuous integration, if we were to measure in terms of agile, we could say that maybe agile is limited within CI/CD. Looking at the agile approach, making sure that any change that is made is integrated, and so on and so on. At the level of agile, you can say that, okay, agile is limited within the framework of CI/CD, continuous integration. Because every change that is made, it is integrated, it is tested, and so on. And all this is automated, it's not manual. Right? So agile actually frameworks basically comes into that. Now, continuous delivery. Now that's where, it is more of DevOps and technical aspect focus. Continuous delivery integration start from the repository, start from your local where you work, right? Writing the code, making changes, integrating new things, getting feedback from your fellow workers, collaborating. That is continuous integration. Now, continuous delivery or deployment. At this level, it is where we got to deploy the application to the UAT or production environment. And in all of this, it involves different type of toolings, different type of skills that you need to know as a DevOps engineer to be able to integrate all these things. Right? So, in common approach, there are some things I usually talked about. I think, let me see, what's the time? 9:30. let's take just some maybe 3-minute break. And then come back so I can go into more depth about CI/CD, define some important things, and then let's just take a 3-minute break.
Prof, please pause the recording.
Yeah, let me pause. Thank you. All right. So when we are talking about CI/CD, so in the world of DevOps, Jenkins is the master. When I do CI/CD, so Jenkins is the master of CI/CD. And why is it so important? First, Jenkins is free. That is one of the most important things. It's an open source tool, right? So you don't have to pay for it in order to use it. You use it for free. So we are going to look at when we're talking about CI/CD. I have a lot of projects here. Which one? Dev project. Let me see how this one looks like. Project. So for instance, now why am I saying continuous checkout? Why do I do this? So you realize there's a way that I name stages within my pipeline, right? Because especially when I'm teaching, this is, I mean, to help in understanding the process. So the first thing, I've forgotten the acronym that I used to use, but I know there's something C something. There's some alphabetical numbers. For those that have taken it, I need to check that. Oh, I can't remember. So the first stage is continuous checkout. Why is continuous checkout? At this level of continuous checkout, basically you are checking out the code from the GitHub repository, right? So I name it like this because I want that when you are building or when I'm explaining it to somebody and the person sees it, they can be able to actually understand what I'm talking about, checking out the code. So, and if I open, you're going to see the code. I'm going to go into the edit and we're going to take a look at some of the things. And then once you check out the code, what do? You have to build the code, the continuous build. When we talk about build, what is the build? Build, in other words, basically converting the artifact, the code into an artifact. And once we build the code, what do? We scan, the code. Static, the artifact, right? To a certain extent, sometimes this can even come before the build. We can scan before we build, or we build and we scan. Make sure so, yeah. So we check out, we build the code, we scan the artifact to make sure that it is safe, right? It does not carry any vulnerability or risk to our systems and cause maybe hackers to penetrate or anything. So we want to make sure that the code is safe, it meets requirement. And here is just conditions that you define. Quality gates, right? At base levels, integrate some important tools. So what am I scanning here? We are scanning with a tool called the SonarQube. So integrate SonarQube to make sure that it's scanned, right? And make sure it passes. Once it can scan, it gives us the results, right, of the code. And you will see it's telling us that the code was successful. It needs to be successful. You need to test to make sure that the process is successful, right? So static code analysis, we could also include, depending on the type of application, it's a web-based application, we could also include things like what dynamic code analysis. We could also include things like, there are different ways depending on the type of application. So it scans the code for any vulnerability, any risks, and all that. And it will give you details, areas maybe to improve, to fix, and all that. And then quality gates here just a condition that you define. What happens if the scan fails? Should it continue? No, the quality gates here is a condition. You say, okay, if the code fails, this is what should happen. It should abort the process, it should not continue. So this stage is going to make sure that it only continues if the code was successful. So if it fails, it will abort, or if it does not pass to the required percentage that is defined within, the framework, it's going to abort. And then continual testing here, you would apply, additional testing. So here, just scanning the code for vulnerabilities and other things, right? So once it passes here, so here, this additional testing, deploy, maybe your testing environment, right? And then for additional testing, that is where you talk about staging environment. So they're going to carry on some additional tests, functional application, and so on to make sure everything works. And then now the artifact is built. You don't just allow the artifact. What do? You upload the artifact, right? You upload the artifact into, a repository, right? If the repository was actually running now, you see, we build an artifact, the .war artifact, right? Extension. This .war is an application, just like we have maybe .NET, maybe we have, every application has its own extension. So WAR here stands for Work Archive. So it's a Java-based extension because this application is a Java-based application, and we are building it for Paradigm, right? So we say that as well as paradigm.war. That is to say, a Paradigm Work Archive application. It's a Java-based application. So it uploads to make sure we have a version. My Nexus server, I'm not sure it's not running, so I have not started it. I'll have to start those things before our next class because we got to be working. So that if I'm talking about something, I can be able to show as well. So that is where it upload the code. Once the code get uploaded, the next thing that it does is what it now deploy to QA, right? Quality assurance or UAT, all depends. Most environments, if they have QA, they don't have UAT. When they have UAT, they don't have QA. And then testing. Most environments will have testing, yeah, which is the same as maybe staging, something like that, yeah. And then from here, they can do what? There are two possibilities: continuous integration and continuous delivery. And what is continuous integration? At this level of QA or UAT, basically they can automate everything up to this level. Why? Because they are very short, right? And to this level, which is a production, a prod environment, continuous delivery. Why did I say continuous delivery here instead of deployment? So now is the question: what is the difference between continuous delivery and continuous deployment? These are very important things. They're going to ask in an interview sometime. What is the difference between continuous delivery and continuous deployment? And you're going to get stuck if you don't understand it, right? So continuous deployment means that everything is automated from up to this level. Continuous delivery, when you see delivery, it means some manual intervention. Manual intervention, that's where it's called delivery. So delivery and deployment, the only difference that makes the two is what? One is automated and one is, one needs manual intervention. Therefore means some human person needs to come in, maybe the manager, is production, right, and manually approve before this can be actually deployed to production. This is an opportunity in an environment where maybe they are still new to the application and they're not quite sure of the level of stability. So they want to be more careful. So maybe they want like a higher authority to take responsibility to say, okay, after every testing, I think let's go ahead and then deploy this and make it available production. Production here is where the consumers and everything, comes into play. If you are using Google, all what you see in Google is what? Production. In the software development lifecycle, there are many stages as well. You hear the beta, you hear alpha, and so on and so forth, right? So those alpha, beta, and all that can also be categorized based on different type of environment. One is more stable, one is functional, but they are still trying to test the more to get more feedback to see what challenges are going to face once the customer starts using them, and so on and so forth, right? So all that aligns. So we are talking about that. So Now, I don't know if there are any questions. So I want to, round up on this concept of CI/CD. What is CI/CD? I want it to be clear as possible. CI/CD stands for continuous integration and continuous delivery. Now, in each stage, for you to be successful in development, you need to understand in what stage. If I do actually in an interview, hey, Madam Mary, please can you tell me, some of the things you have done, or can you tell me about yourself? You would, you're talking about in the context of those who say, you have built what pipelines, right? So, and in doing a pipeline, basically, you take charge of what in the environment. You are the main development guy, and you take care of the CI/CD pipelines, right? And what CI/CD continuous integration, continuous delivery. Now, for my continuous delivery, each stage has a particular tool that is used in every environment. A lot of continuous delivery. First, because when they will say, okay, you say you are a development engineer, this and that, can you walk us through the process? How do you manage your pipelines? Can you walk us through? You will say, yeah, in my environment, we use Jenkins, or we use Azure DevOps, or we use whatever CI/CD tool that you use. The concept of CI/CD is the same. You don't matter whether it's Azure DevOps, AWS DevOps, Jenkins, or you are using, is it, there are a lot of tools out there. It remains the same. So now we use Jenkins, and basically my pipeline, this is how I manage my pipeline. In my environment, I use Jenkins for my pipeline, and with that, we do use JIT. So basically, JIT is our code base. So whenever the developers develop the code, they deposit the code into a GitHub repository, and when they deposit the code into a GitHub repository, basically, that's where I pick it. My pipeline download this code, Jenkins download or check out this code, to the server, and then once you check out the code, it builds the code. So now we actually use what? We use Maven or whatever tool I use in environment. You take the code for build or Gradle, or it could be NPM, depending on type of project. If you're using, for instance, Node.js project and all that. So I use, Jenkins. I use Maven to build the code. And once the code is built, right? So the code is tested, right? Because we actually use, for instance, in my environment, because you always want to talk about what you have done. They don't want you to be saying you could know. Be telling them what you have done. That's what they're interested to hear. So I use when man build the code, now the code is scanned, right? So we use, not Nexus yet. The code is scanned with, for instance, SonarQube. We analyze the code to make sure that the code is served, so that we should not carry a box to production or carry any vulnerability and all that. So it could be Selenium and all that. So you need to state the code or whatever testing framework that you're using to test your pipeline. So, and then once it is tested and everything is working well, so we deploy the code to staging, right? In the staging, what they do, you would explain. So maybe they need additional testing and then integration and so on and so forth. So once everything is functional and is confirmed, it is deployed to UAT, right? And so once you are talking about any step, you need to state what type of tool do you use, right? So for deployment, for instance, maybe in this process, we build using what? We check out with Jenkins. We build with Maven. We do static code analysis with SonarQube, right? And then we deploy using, for instance, Tomcat. We are going to see Tomcat. We use Tomcat, which is a server. Each application that runs out there are different types of applications. It could be a web-based application. It could be a server-side application. So when we're talking about applications, it could be a web-based application. It could be a server-side application. A web-based application could be maybe a website. Yeah, a website that's open. A server-side application could be, for instance, Node.js, right? It could be, for instance, Tomcat, JBoss and all that. Those are different types of server-based applications that are used to deploy applications that can be made, utilized that by customers. So you need to state exactly what you are using. So yeah, I use, for instance, Tomcat to deploy the application, and with the help of maybe plugins, which you are going to see, with the help of plugins like copy to container plugins, or with it. So you state all those things. So you're going to keep that. That's what I use. And then when you talk about deployment is just a technical term. In other words, when you talk about deploy, it's basically copying an application to the desired system to which you want to use. In other words, it could be and then installing. It has to do with copying and then installing. Do you see that?
So
Go ahead.
Prof, so it looks like it looks like copying data from one server to another server.
Yes. So that's simply the whole idea of deployment. When they talk about deployment, it might sound like something. It's just the technical term, the jargon of what DevOps or development and IT. We talk about that. So it's simply copying to another server. That's what deployment is all about. So yeah, then installing where you have to use. So you deploy the application using that, and then once the application is deployed, what do? Then, and so on. You continue to do what to monitor the application. And in my environment, I use, Prometheus and Grafana, which is what we are going to see. Some of these I'm mentioning some of the things we are going to see how to use them, build end-to-end pipelines and all that. Prometheus and Grafana, you could use, it could be Splunk, it could be whatever, right? So, and so on. So you're gonna state them how you manage these stages and all those sort of things. Now they will listen to you. Now they can start asking you questions. You say you use maybe Nexus. What is this on Nexus? You say use and all that, and that's how your interview is gonna work. So just from you telling them what you have done alone, they would start deciding whether they can hire you or not. Because first, when you start babbling or rambling, I mean, it's difficult. What you work on, you don't face difficult talking about. So that's why no matter how good you are in this thing, they always say you must make a story around the whole thing. So one of the things that we are going to do at the end of this process is be able to tell a good story about what we are doing in a way that's going to captivate somebody to want to hire you. So even if you are lying, you mean to make sure you lie in a way that somebody wants to buy into that lie, because basically they believe what you tell them. If you sell yourself cheap, they're going to believe it. Yeah, you're going to believe it. Why do you take this guy, man? So that's how it's going to look like. So you got to be able to tell the story around the whole thing. So that's what we're going to achieve. We're going to get comfortable with those type of different tools, know how to integrate them, use them, and at the same time, we're going to be comfortable to talk to somebody about it. Anybody that's going to want to hire you with confidence. That's what we're going to achieve. So at the end of the day, like I said, I'm trying, because I'm trying to throw a lot of information at the same time. But I'm believing I'm talking to people that are not coming or are not new, right? So I try my best to put it, the way I can simplify it, so that by our next class, right, we are going to go into Linux and start doing Linux, so we can take, a few sessions on Linux and JIT. Sometimes we are just go with Linux and JIT at the same time. We can take one session or two sessions and then work on Linux very well, right? So I'm going to teach Linux in the most simplified way. And then we will now start going to JIT, right? So, and all that. Once we go into JIT, everybody should be comfortable, because you cannot do DevOps without JIT and Linux and all that. So we can go more and more, and so on and so forth. Like at the last, we have Prometheus and Grafana. So we need to make sure that our application is continuously monitored. I don't think these servers are running, so we're going to see everything. And we're also going to set them up, right? So we could set them up using containers or directly, but I think somehow we are going to end up using containers, because it might be maybe simplified as compared to, because these are heavy applications running on your computer, and if you don't have a very big computer, it will be difficult for you to virtualize and have everyone having a server running a particular application and all that. And I think that is all about for me. If you must remember something today, remember what I've given, the background, right? You don't need to remember everything, but just think about it. If I ask you what is waterfall methodology, what is agile, right? And how we came about DevOps, what problems have we solved? What is agile? I mean, you should be able to tell someone what's agile. You should be able to tell someone what is a sprint, filtration, and a few things, that story in your own words. And then DevOps, right? At least you should be able to have a simple definition of DevOps in your own way. Whatever, first, you know it derived from two words, that's development and operations, right? Where the two merge, so that they should stop working in silos and then be able to collaborate. So, which is one of the principles of what? Of the whole collaboration, simplification for easy management, and also shorten time to market. So you must be able to put those things in context, talk about them with ease, and then you must be able to explain what is CI/CD, continuous integration and continuous delivery, right? CI stands for continuous integration, right? It means that at every level, when the code is developed, it is integrated. And even if it is a dot that change, it is integrated, build, test, deploy, and so on. Even if you remove just a minus, you are going to integrate, build, test, deploy, and everything. So at every given time, if you make changes 10 times a day, it therefore means in normal circumstances, you are going to do deployment 10 times. So it makes sure that what the process simplified, just like you've seen in Agile, break it down into smaller bits. You don't have to develop a bulk application, right? A very maybe a 1 million code, and then you are without testing now. Once you are done the testing, done developing, now you start testing and you start failing. You don't know where to start. That is the problem with waterfall that we have tried to overcome from Agile to DevOps. So we don't have to wait that long. No, we test every stage of the way, and we integrate every change that is made. We don't have to wait, and make that change readily available for consumption immediately. Everything is working as it should. We don't have to keep our customers waiting for 1 year, 2 years when we can do it now. So shorten time to market. So what does that mean? DevOps is customer prone, and everything Agile from Agile to DevOps is about customer centered. So put it in your own way, the way you could put it and all that, and make a summary of it so that you should remember, which is very important. So I think that's all for me. And if there are no questions, I would let us go, and we're going to continue in the next class with more practical, hands-on, and everything. Please feel free at any time when I'm teaching, stop me, ask, sometimes I'm fast and all that. And then we could, be sure that we're going to get it together. Yeah. Thank you.
Sure, thanks, Prof. So, Prof, what are we studying on Saturday? You said it's Linux?
Yeah, so we are going to go start with Linux, yes.
Okay, so I already have my virtual machine installed, and I also have my mobile extend installed.
Right.
So I was just wondering, are we going to use that, or you want us to install something else?
No, we are going to use a mobile extend, so that's already a good one. So if I have a VM, that is already a very good. So it means that we are not going to come again with saying we want to start setting and all that. So you are good. I think you are good. What is it, Ubuntu? What flavor of Linux are you having?
No, I have multiple flavors. I have Alma Linux, I have Ubuntu, I have Red Hat.
Okay.
I think I had 8 or 9. Yeah, I've just used anyone all the time.
Very good. So that sounds good. It sounds like you are ready for this.
Yes, I am.
Good. No, you are good. So mobile extend, we use mobile extend, so you are good.
Okay.
Yeah.
Thanks,
Thank you.
Prof.
All right.
Sure. Thank you for your class.
Have a good rest.
Thanks. Bye.
Yeah. Good night.
Good night.
Yeah.